Hello everyone, welcome to ArchMaths. Ever wondered what day of the week historical events fell on or your birth date in the past? Fear not, for we hold the key to unlock these mysteries, the Doomsday Algorithm. Join us as we venture into the intriguing world of the Doomsday Algorithm, a clever method to swiftly reveal the day of the week for any date within a year. We will decode the steps, unveil hidden patterns, and journey through time. Picture this: on the Doomsday Algorithm, you will transport yourself back in time. With this timeless skill, you will navigate historical moments, witnessing the past in a whole new light. From revolutions to personal milestones, the Doomsday Algorithm becomes your guide to unraveling the days that shaped our world. Are you ready to embark on this captivating journey through time? Let's get started. The Doomsday Algorithm revolves around the doomsday for the century and specific dates in each month that falls on a doomsday. These simple codes link weekdays: 0 for Sunday, 1 for Monday, 2 for Tuesday, 3 for Wednesday, 4 for Thursday, 5 for Friday, and 6 for Saturday. Let's simplify the process further. Certain dates within each month always share the same weekday. For example, 7th of March, April 4th, and more. By knowing these fixed doom days, we swiftly calculate any date's weekday. Conway selected these specific doomsdays for each month due to their ease of remembrance. When you examine these dates numerically, a clever pattern emerges. Let's break it down. Let's start with the even months, except for Feb, 4th of April, 6th of June, 8th of August, 10th of October, and 12th of July. Notice that the even dates are remarkably straightforward to memorize because their doomsday correspond to the same number as the month itself. Now let's explore the odd months. While their rule is not as effortless as the even months, it is still manageable. For odd months with the 31 days, you simply add 4 to the month number. For example, 7 by 3, 3 plus 4, okay? 9 by 5 and 11 by 7. This rule. On the other hand, for odd months with only 30 days, you subtract 4 from the month number. For instance, 5 by 9 and 7 by 11. Adhere to this pattern. However, there is an exception to remember. Jan, although it has 31 days, you don't add 4 to the month number. By understanding and applying these straightforward rules, you will effortlessly navigate the calendar's intricate tapestry and unveil its hidden patterns. Before applying the Doomsday Algorithm, let's take a look at its steps. Firstly, we find the doomsday of the century, and then we write the weekday code for that doomsday and denote it by A, and then we divide the last two digits of the year by 12 and get the question which denote by B and get the remainder which is denoted by C, and then we divide the remainder by 4 and denote the remainder by D. Then put them in this formula. Let's put our knowledge to the test with historical dates. Time explorers. With the Doomsday Algorithm, you have unlocked the secrets of history. Keep decoding, keep exploring, and celebrate your mastery over time's enigmatic patterns. First, we will determine the doomsday for the century. For the 1900th century, the doomsday was Wednesday with a day code of 3. Let's designate this as A. Next, we divide the last two digits of the year, that is 47 by 12. We get a quotient of 3 and a remainder of 11. We will denote the quotient as B and the remainder as C. Now let's divide C by 4 to get a remainder of 3. We will denote this remainder as D. The next step is to use these values in the formula. E equals A plus B plus C plus D equals 3 plus 3 plus 11 plus 3 equals 20. Okay, now subtract 14 from E, which gives us 6. It should be less than 7. What's the day code for 6? It's a Saturday. Moving on to find the Doomsday for the month of August. The anchor day for August is Saturday. Counting forward, we will find that the 15th of August 1947 falls on a Friday. With the Doomsday Algorithm, you have unlocked the secrets of history. Keep decoding, keep exploring, and celebrate your mastery over time's enigmatic patterns.